All right. Now, today is a little bit different, just because I'm podcasting this hour. And like I said, breaking a new computer, so things are a little bit different, the way things work, but we're working on it. But I want to take just a minute to review some of what we did on Tuesday of last week. I want to say Friday, but it was Tuesday. On Tuesday, we dealt with the idea of angle bisector. And that was a big thing. And if you were not in class, be sure that you go back and watch that podcast, because there's a lot of drawing that was done and demonstrations with Sketchpad and stuff like that that are pretty important that you won't get from looking at the notes. You really do need to watch that podcast if you are not here. I'm going to summarize it real quickly, but it's not the same as seeing the way it works out. With an angle bisector, I'll draw an angle in here best I can. An angle bisector. Remember, an angle bisector does exactly what it says. It bisects an angle. So that means that these two angles are congruent. That's an angle bisector. If that's true, every point along this angle bisector is equidistant from the sides of the angle. And the way we measure distance from a point to a side is with the right angle distance. Those two right angle measurements have to be the same. Now, I'm not drawing perfectly to scale here probably, but you get the idea. And one way to tell it's an angle bisector is if these two distances are the same. Now, if we don't have the fact that those are right angles, if I just have that those two segments are congruent, that is not enough information to get angle bisector. Just because those segments are congruent doesn't mean they're the right angle distances. Distance is only measured at a right angle from the point to the side. We also do not measure the distance at a right angle to the bisector. Okay? That's a no. We don't do that. We measure the distance at a right angle to the sides. And every point on that angle bisector is equidistant from the sides. When I get in a triangle, and all the angle bisectors of a triangle drawn in, then we get what's called an in-center. That point is equidistant from all three sides of the triangle, and it's the center of a circle that would be drawn perfectly inside the triangle. I don't have a good picture of that. Maybe, I don't know if I have that in my notes from last time. 5-3. Take a look at that one. Not sure if I got a good picture of that. These are some of the notes. So here we go. Here's all three angle bisectors drawn in. This point is called the in-center. Again, it's a point of concurrency. And again, that in-center is the center of a circle that fits perfectly within the triangle. It's tangent to all three sides. Now notice that the congruent distances here are in red. Okay, those distances are not part of the angle bisector. The angle bisectors are in blue. The distances are in red. So that one's off a little bit, but you get the idea. Orientation's a little bit off with this new. I got to work on that. So that's what's going on with angle bisectors. That's what we did on Tuesday of last week. So it's just a real quick review of that. But again, if you missed that or if you don't remember that at all, you probably want to go back and rewatch that podcast. You know, a lot of people were kind of mentally checked out even if they were here, because it was the end of a long stretch. Now, while speaking mentally checked out, just a reminder, we are in the 5th week of the quarter right now, so midterms will be coming out end of this week. So that's our first midterm grade notice. We aren't doing tri-terms anymore. We're just back to midterms again. And by the end of this 15 days between Thanksgiving and Christmas, by the end of this 15 days, we only have like a week and a half left, even less than that. Actually, we have like 7 class days before exams. After Christmas. Okay? So this 3-week period is very, very critical to your grade. You really can't go home, hit Christmas break, New Year comes along, you make a resolution, I'm going to do better in math. Honestly, at that point, it's almost too late. I mean, you could probably still make minor changes in your grade, but not big ones. You're not going to have that 20% swing anymore. So if you want to make some changes in your geometry scores, these next 3 weeks are critically important. And keeping up with things over these next 3 weeks. That's where the difference is going to be made. By the time Christmas is over, it's too late. By the time we come back, we only have, like I said, I think it's 7 class days before exam, maybe 8. Yeah, it's 8 because that Monday is not exams yet. It's not exam week. So, but, 2 or 3 of those days are probably used up on review. So most of what's going on will be done. Why? To evaluate summatively what you have learned, of the things you're supposed to have learned. We have all these learning targets and essential learning outcomes that we post all over the rooms and on the boards and stuff like that. And there's a point where we need to evaluate if you've actually learned those things or not. And that's where it's done. So that's how we evaluate that. An exam in here is 20% of your grade. The exam here is also almost all multiple choice. 90% of the points come from multiple choice and 10% come from proofs. So 10% of the score comes from proofs, 90% comes from multiple choice. Yes. Depends on where your B and where the D is. If you're a middle of the road B, a D probably will still probably the B. If you're like at 80.2% B minus, then the D will probably drop you down to a C. So it really kind of depends on where you are and what's going on. But most people don't change their grade via the exam. It just pretty much confirms your grade. Is what it comes down to. But it is required. I mean, the district requires that we get exams. Everyone has to. So anyway, that's what's going on for the next few weeks. Also, just a quick reminder, Unit C retakes we're done with now because we're in a Unit E. We gave you a few extra days on them, but anybody who had not taken anything from Unit C that was still in Test Center, I pulled that out this morning. So that's done. Unit D retakes you can still work on through next Friday. So if you have any retakes from Unit B that you want to still do or work on, tests, benchmarks, whatever, those need to be done by next Friday. And Unit E will pretty much continue until the end of the semester. There are no retakes after semester exam. When we start second semester, a lot of you are switching sections anyway. Some of you are switching to a different teacher. Some of you are switching to a different hour of mind. Some of you are staying put. It's about a third and a third and a third. And the computer generated that ages ago. So it's fine, but realize there's no carryover grade-wise. You can't go back in second semester and retake something from first. When semester's over, it's over. So let's really be working these next 3 weeks. Let's not be kind of blowing things off saying, it's December, I really don't want to work in December. It's a bad month if you make that choice. Because there's a lot going on. All right, so that was angle bisector. Today, we're going to work on median. Now, a median is a segment that connects a midpoint to a vertex. This is a median. See it as a midpoint? It's connecting to a vertex, the opposite vertex A. Not just any vertex, it is the opposite one, but it wouldn't make sense to go from C to D. That's a vertex, but that's already part of a side. Same with C to B. That wouldn't be anything that exciting. Of course, it's the opposite vertex. It's the only one that really makes sense. A median should not be confused with a midsegment. The midsegment connects midpoint to midpoint. So if I had another midpoint here, we'll call this point D, and call that a midpoint. That's the midsegment. Midsegments are parallel to a side, half the length, all that deal we got earlier in the chapter. Don't confuse a median with a midsegment. They both start with the letter M. They both use midpoints, but one goes midpoint to midpoint. That's the midsegment. The median goes from midpoint to vertex. Just like with angle bisectors and perpendicular bisectors, you may want to get the door. Just like with angle bisectors and perpendicular bisectors, medians have a point of concurrency. So all three medians, if I draw all three medians in the triangle, they'll all come to a common point. That point is called the centroid. The centroid is an interesting point. We had the circumcenter. That was where we centered the circle that goes around the triangle. We have the in-center for the angle bisectors. The in-center is where we get the circle that goes inside the triangle. Hence the name in-center, because the circle's in the triangle. It's nice. The centroid is kind of interesting because the centroid has a couple properties that are useful for us. First off, the centroid is what's known as the center of gravity of the triangle, the center of mass. Which means basically if you were to cut out a triangle, and I've done this in the past, we just don't have time to do that right now. But if you were to cut out a triangle, find the midpoint of each side by folding, it's pretty easy to do, and found the centroid of the triangle, that point, you could probably balance that cut-out triangle on the tip of a pencil right at that point. That's the balance point of the triangle. It's the exact balance point. So as long as the material is consistent, or you can go home and do that. You can, get a scissors and cut out a triangle and try it. It's pretty easy. That's the balance point of the triangle. The other thing that's interesting about the centroid, though, and the one we actually use more often, is it divides each segment proportionally. And this is unique. This is the only one of the points of concurrency that does that. It means that for every unit of measurement we have here, x, from the centroid to C, we have 2 units of measurement here. Or if I went along this median, for every y here, there's 2y over here. Or if this is my one, for every z I have here, this is twice as long. There we go. So the centroid is kind of interesting in that it divides things proportionally, and that's actually the fact we use the most in the home, is that proportional division. That's what applies to us most often. So, pretty simply, if I tell you that xc here is 5, how long is ax going to have to be? 10. Has to be twice as long. And if I said that, what if I said ex here is 2x, and xb is 6x plus 10. How are we going to set up and solve an equation? Obviously, 2x doesn't equal 6x plus 10. One is twice as long as the other. Which one do I have to multiply by 2? The short one, right? Always multiply the short one by 2 to equal the long one, if it's a double half thing. We did that with medians, too. So 2 times 2x equals 6x plus plus 10. So 4x equals 6x plus 10. Oh, it's not going to work out. I should have made that minus 10. Sometimes I make it up on the fly. It's okay. I can fix that. So if I subtract the 6x from each side, I get negative 2x equals negative 10, so x is 5. Now, obviously not drawn to scale here. That makes this 10 and that 20. But it works out. Or ignore the fact that we had 5 and 10 right before. So I can set up and solve equations using this fact. Another thing I can do just very quickly is I could also do the whole idea, sometimes they give us the picture, and instead of telling us a part of this median, they give us the whole thing. So if I have a triangle, and this is a median, and midpoint, say here, okay, that's my other median, so that's my centroid right there. I only need 2 lines really to find the centroid, right? Because all 3 will intersect the same spot. So that's my centroid. And let's say this is A and this is X, and they tell us AX is 33. Call this point C for centroid. And they ask us to find the lengths of AC and CX. Remember, it's dividing in a 2-to-1 ratio, so we're dividing into 3 parts. So I could say 1/3 of 33 goes here and 2/3 of 33 go here. But since most people don't like to multiply by fractions, like 1/3 and 2/3, let's prefer not to do that. I say this: take the total length divided by 3. That's easy. It's 11, right? 33 divided by 3 is 11. So that means this gets 1/3 of that, or 1 part, and this gets 2 parts. 22 and 11. 2-to-1. 1 part to the short part, 2 parts to the longer part, divided by 3. 1 part, 2 parts. See, if I divide by 3 and get 1 part here, that's 1/3, right? If I divide by 3 and get 2 parts, that's 2/3, right? It's just a different way of thinking about it, but it tends to be a little easier for a lot of people. And like I said, a lot of your homework revolves around that idea of this. Another thing your homework tends to look at is this sort of thing. Here is coordinate plane work. We need to find the centroid of this triangle. Find the exact location of the centroid. Well, let's start by finding the vertices. We'll call these points A, B, and C. A is at -1, 2, so we'll put that in. B is at 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There's B at 5, 6. And C is at 5, -2. And I can very easily draw in the sides of my triangle. And there's my triangle. Oh, hooray. In order to find the centroid, I'm going to have to find all 3 midpoints, aren't I? And to do that, we'll need to use the midpoint formula. This is one that we haven't used a lot, but we will. And again, these are the 3 big formulas that we keep using over and over: distance, midpoint, slope. Those are our big 3. You need to know them and be able to work with them. So the midpoint formula here for AC. Remember, we add the x divided by 2. It's the only time we add, other times we subtract. And 2 plus -2 divided by 2. 1 plus 5 is 2, or 4. 4 divided by 2 is 2. 2 plus -2 is 0. 0 divided by 2 is 0. So 2, 0 is the midpoint. Sure enough. So here's one median. Next midpoint, let's find the midpoint here. 5 plus 5 divided by 2. 6 plus negative 2 divided by 2. 5 plus 5 is 10. 10 divided by 2 is 5. 6 plus negative 2 is 4. 4 divided by 2 is 2. So 5, 2. There's my second median. Yeah. Doesn't matter. Because you're adding, it doesn't matter. 3 plus 5 is the same as 5 plus 5 is the same as 5 plus 6. Adding is cumulative. Third midpoint. Negative 1 plus 5 divided by 2. 2 plus 6 divided by 2. Just so long as you got to remember to add the x's divided by 2, add the y's, not add an x and a y. That's the biggest thing. If they're in parentheses together here, they better not be together here. 4 divided by 2 is 2. 8 divided by 2 is 4. 4 is right there. Again, we connect the dots. And where is our centroid? It looks like we're right at 4, 2. Would appear to be is it 3, 2? Sorry, I miscounted. 3, 2 is my centroid. And we can kind of check to make sure, because it's nice and horizontal. This is 2 units long, this is 4 units long. Sure enough, it's dividing proportionally, isn't it? Twice as long. I could do the same thing using distance formula to prove that these two are twice as one is twice as long as the other, and these two, but I don't need to do that at this point. All we're going to be asking you to do is be able to find it graphically, which means you have to find the midpoint. Now, the last thing we're going to talk about is the altitude. The altitude we don't spend a lot of time with. The altitude is the height of the triangle that you learned about when you were back in 4th grade or whatever, doing base times height divided by 2. That's the altitude. It's perpendicular to a side. Sometimes the altitude is outside the triangle. Sometimes it might be towards its midpoint. Sometimes it's not. It really depends on the triangle and where we're at. But that's an altitude, the red line there. The altitudes do intersect at a point of concurrency called the orthocenter, but we are not going to concern ourselves with the orthocenter. Orthocenter means straight center, literally translated. Ortho is a prefix meaning straight. Orthodontist. Straight tooth. Tooth straightener. Okay. But there's nothing interesting at all about the orthocenter of a triangle. Nothing that I've ever found. It's really quite dull, so we don't worry about that. You know it exists, it's not that important. But you have to know what an altitude is. This picture, however, is very, very important. Because you now have all the special segments in a triangle, and you need to be able to identify what is what and distinguish the properties of each. And that's where it gets tricky. Notice, the perpendicular bisector, the green segment, is perpendicular to a side, but does not go through a vertex. It's the only one that doesn't go through a vertex. The rest all go through vertices. The median connects the midpoint to the vertex. The angle bisector goes to the vertex, but doesn't do anything else special other than divide it equally. And we do have these angles being congruent. That's it. The altitude comes down and forms the right angle, but does not necessarily go through the midpoint. Now, can they all be one? Can they all be the same? Absolutely. In equilateral triangles, all 4 of those special segments are exactly the same. In fact, all 12 of them are. In isosceles triangles, if this is the vertex angle, then all 4 of them are the same. But otherwise, they're different. So usually they're different, and we need to memorize them and be able to identify them and know their properties. That's a picture you want to copy down. If you haven't done it already and you don't do it, you might want to at least print it out, because that's an important picture, being able to identify what's what. I suppose go ahead, take a picture. That helps you. I'm not sure how well the resolution's going to come out if you take a picture of it, but yeah, it's quality. But this is something you want to know. This is something you definitely need to know, because that's what we're going to be focusing on tomorrow, is working with all of these together to be able to distinguish what's what. And tomorrow we're reviewing already, and we're already taking our first benchmark for our second benchmark for this unit on Wednesday. So time's a wasting. We're moving right along. Your assignment is pretty short. 3 through 11 and 33 through 35. It's a pretty short assignment. Very doable. Tomorrow we'll have a review sheet, and Wednesday's already a benchmark. So make sure you are keeping up with what's going on here. Don't let yourself get behind. We still have a few minutes, so you could probably even open up your book and actually get started on a few of these problems without too much difficulty. I will check in yesterday's tomorrow. I don't have time to do it right now. That's fine. I'll check it tomorrow when I come around checking homework. Show me that. Today is indeed the 2nd, all day long. How about that? We're in December. It's going to feel like December later this week, too.